So normally I like to start my talks with a little bit about why we're having this conversation today. This is the part where you can fully commit to the talk and you can make a decision if anything in this talk resonates with you. So this course is for UI engineers or engineers in general that feel that testing takes too long, or that it's too hard, or that they feel that they never know how to architect code to essentially make it testable. So it's really for people that, you might have been doing development for 2 years, you might have been doing it for 20 years. If you are still feeling that you haven't gained a big picture idea of how to test an app, specifically a JavaScript UI app, then this is what this talk will hopefully help you with today. So what we're going to be doing is we're going to try and understand what stops you writing great tests in a JavaScript app. This talk has got 3 parts to it. The first part is called the lean testing philosophy, and what we'll be talking about there is a mental model, if you like, on how to make good decisions with regards to your approaches to testing an app. Then we're going to be looking at the two other topics which fundamentally make up the thinking behind this course, if you like, and that is testing the whole and then something called the framework trap. Testing the whole is about how we put together apps so they are more holistic, and the framework trap is probably the #1 thing that you need to try and not get into, and if you are in, then hopefully get out, and hopefully you'll learn a bit about getting out of the framework trap today. At the end of this talk, there is a follow-up option, so I'm going to try and get done well before 1 o'clock, so we can have some questions and whatnot at the end. So before we go any further, just a little bit about myself and what my story is. So my name's Pete, and I'm the founder of Logic Room, and we started 2 or 3 years ago. We are a training and consulting company, and in this picture here you can see some of the engineers that we hired. And what we've done over the last few years is we've been using a methodology to design software, JavaScript apps for our customers. And this methodology, it's a part methodology, part training course, has been in development for the last 6 years. And I started creating this methodology about 6 years ago. I was working on the South Coast. I was a contractor, and I started on a new project there. And the manager who hired me said to me, look, we do TDD and we do BDD, and he threw all the buzzwords at me. And I thought, fantastic. This is what I want to be doing. And I started there. And on the first day, one of the lead engineers said to me, he said, our tests, they run overnight. I thought, OK, fine. And he said that they take 12 hours. And that was, I realized that was a really big problem. I looked at my watch, realized this was a really big problem because the office only closed for 11, which meant that when we got in the morning, the tests were still running if we'd kicked them off the night before. So I realized that what was happening is that they didn't have a very good way of testing their apps. And so they were forced to do a lot of heavyweight integration testing and what they were calling BDD testing, which wasn't actually BDD testing. But what they'd done is they'd created this very complicated architecture, and therefore they were forced into a very complicated testing scenario. And what that meant is that the code was ultimately fragile, and so were the tests. And for that reason, we just couldn't iterate quickly, which sort of defeated the whole objective of having tests in the first place. So I set about designing this course to actually try and improve, to try and find a way to create a course that could, firstly help these engineers I was working with, and then also help other engineers. So this course, it's battle tested. The things that we teach are battle tested. They work really well. They've worked really well for us and our clients, and they can work well for you as well. And so just before we sort of get into it, imposter syndrome, I know, is something that is very common with a lot of people. Certainly something that I've had. And what imposter syndrome says is, I can't do X, Y, Z, or I'll never figure out how to do X, Y, Z, or I'm not good enough, or anything like that. And so you need to just get rid of those thoughts out of your head entirely, because what you realize with imposter syndrome, the same as for anything you learn in engineering or anything in life, is that you just have to have the right process. Okay, so you can, if you are struggling to do testing or TDD or any of these stuff, you just need the right process, and hopefully you're going to get a little nugget of that process today. So the first thing we're going to talk about is lean testing. In front of us, we have a diagram here. This diagram was created by a Hungarian psychologist or philosopher called Mihaly Csikszentmihalyi. Now I won't put his name on the screen because it's just really long, but I had to actually go and find out the phonetic pronunciation of it. But what Mihaly said was that when we approach any task, we can get into a state called flow. And what flow means is that if you take challenge on the left-hand side of this graph and you take capabilities across the bottom, if the challenge is relative to the capability, or rather if the challenge is too high compared to the capability, it gives us anxiety when we do the task. If our capabilities get too strong compared to the challenge, then we get boredom, right? But if we have a matching over time between challenge and capabilities, we end up in this bit in the middle, and this is called in flow. And the state of flow is recognizable because you are happy, you have low anxiety, you're productive, and generally, I would say that this is where a professional should aim to be, especially an engineer, because if they're in that state of flow, that means that they're progressively moving on in their capabilities with regards to constructing code, and over time they can, the capabilities are matching the challenge. And what this means is that this means that as you grow a code base, your code should not become too bloated and too badly architected, and that over time you can still scale that code base, right? So what does this mean for testing? What this means is that if we slowly grow a code base and we have over time the code stays scalable and it stays everything is good in that code base, this is what good testing looks like. And good testing takes us down the flow channel, right? It takes us individually down the flow channel, and it takes our colleagues, and as a team should be able to continuously test that code base to any size of the team, right? And you do that by having a good testable architecture. But you see, bad testing obviously will, the challenge becomes too great quickly, and compared to the capabilities. And I'm sure we've all been down this one, and this is the 6-month point. This is where we start an app, and then 6 months down the line, it just becomes too hard to test, so we give up, right? And so we don't want that. We want to stay in this middle zone, and creating a good UI architecture is how we do it. So you might have seen this before. This is called the testing triangle. And what the testing triangle says is that if we imagine all of the testing within our app, at the bottom we have unit testing. And the unit testing is the simplest type of test that we can have. And what happens with unit testing is that we have lots of them. So that's why it's at the bottom of the triangle, and it's a fat triangle. Then we have integration testing, and the integration testing is the next part, which wires together various different parts, and we go all the way up to end-to-end testing, right? And this testing triangle is a very common way of understanding how many tests roughly. It's a mental model for how many tests we should have in a code base. But if we actually think about it, really what we should do in anything in software development is we should realize there's no such thing as best practice that we might see here, right? It really, everything is just a payoff compared to the difficulty of the thing, right? So we're going to get some payoff, but some things might be too difficult compared to what we're going to get from them. So in other words, we have to create balance in the conceptual models that we bring to building software. And in front of us is another way, a bit like Mihaly's diagram of putting payoff against difficulty. What it says is that at the bottom you have a unit test, and that is the minimal payoff with the least difficulty, because a unit really just tests a little function or a little bit of code. It doesn't really do a lot, right? So you don't get much payoff, and the difficult, but it's really easy. So you can do loads of them. And then right at the end you've got E2E. Now E2E testing and browser testing and all this stuff, is really difficult. It's really difficult because it's complex, because you have to dig around in HTML, you have to run complicated tools, you have to make sure it's set up on the CI server, etc., right? But the payoff over time will go up and up, and comparatively, compared to the difficulty, you actually see a big drop off, right? You're going to see that the payoff becomes less and less because of that difficulty, right? So really what we want is we want to find the sweet spot. And the sweet spot is our testable UI architecture, right? If we create a testable architecture, we are going to be able to test it more with unit tests that test larger parts of the app. So what we say is that instead of just looking at it as a triangle, what we can do is we can optimize, and instead what we can do is we can focus on creating a good architecture. So when we focus on the testing, what we get is we just get tests, lots and lots of tests and lots of tools and lots of people with their own, preference and what they do. But actually, if we shift the conversation away from that and just say, well, let's make a really testable UI architecture, what we can then do is we can start to use a simple unit testing framework, but we can start to run those unit tests like mini specifications that are actually going to invoke the entire application, right? So that's the foundational theory to this particular talk that we're doing. So next, the next two things that we're going to focus on is testing the whole, and then we're going to look at the dangers of being in the framework trap. So in front of us, we have, this is a state machine. And what the state machine says is that everything can start in some sort of state, then there's a process, and then you have some sort of end state afterwards. And what the state machine can do is this will typically describe what would happen in a piece of software. As engineers, we are paid to make predictable software. The customer wants our boss or whoever wants a button. When you click it, something will happen. We want it to be predictable for the 99.9% of cases. And what we can say is that the state theory should just be taking our app through one state. Now, that one state is contextual, because that one state may have many substates that make up that state, right? And so we may, in this example, we've taken a car which is idle and then accelerates to 60 miles an hour, and we've said, well, actually within that, there's a few different states that are important, such as starting the engine, engaging the clutch, rotating the wheels. Now, normally what happens with taking in mind this state-based approach to testing, which is the right way to do it, normally what happens is that the frameworks that we typically go to, right, React, Angular, Vue, doesn't really matter, they're all pretty much the same, even the second generation ones such as Backbone and whatnot. So all of these frameworks give us tools with which to test our app, and they suggest and maybe even promote, depending on how much you read into the documentation, this concept of mocking and isolationism. What this says, and I've taken these from the respective websites. If we just have a look at this React example just here, what this is saying is that they have this test, and what's happening here is they want to test something in contact. So what they do is they mock out the map module or object or whatever. And what happens is that then they can then assert the state of contact, right? So they can start the contact, then they can do something and then load the map, and then they can say, is the contact done something, right? That would be the React world. In the Angular world, we have this concept of testing modules, and they've done something similar, but the difference with Angular comes loaded with extra tools that are actually quite powerful. But what this does, this shifts the conversation to inversion of control. And what this does is this gives you something called a container where you can start to. It's a different way of bringing out mocks and hiding things. Now, these are really, really great tools, but if someone doesn't really focus on a testable UI architecture, they can often become a bad thing long term, put it that way. And here's why. What they will often do is they will force us to break our application down into lots of mini state machines. Okay, so they will say, hey, I want to test the contact. Well, I'll just do that as its own state machine, and it doesn't really matter about its interaction with the map. What I'll do is I'll just mock out the map, and then I'll run the contact in isolation. And with the Angular one, we've got this master service and test service, and I'll mock out the test service, and I'll just run the master service. So what we get is the UI frameworks almost suggest lots of different state machines, all running with things isolated. And what can happen is that we can run all of our tests, and although all the tests pass, we've actually made incorrect assumptions between the interaction between the pieces, right? And what happens is that we get something called a false positive. So we run all our tests, but we're actually not actually testing the interaction between the two, right? And this means when this happens, what this means is that we are forced to have to move our tests up that testing triangle into the integration tests or the end-to-end tests, right? And those things are complex. So what we need to do is we need to focus on building our app. If we want to test the whole, we need to focus on shielding our architecture, our testable architecture from the component. Right? By component, what I mean is from the framework component, right? Be it React, Angular, or Vue, right? So let's just go through it. So if we want to avoid this situation of isolationism where we think everything's working, but it's not, and we want to avoid the brittleness of being forced to use integration testing to test this system as a whole test, then what we have to do is we have to start to think about rules. And one of the rules that we teach is the rule of the black box. And the black box says we're going to create a testable UI architecture, and we're going to keep the component outside of this particular architecture. Okay, so this moves us into something called the framework trap, right? So this builds on top of testing as a whole. So we say we do want to test as a whole. It's important. So we want to avoid mocking, but to do that we understand that we create this black box. But when we create the black box, what we have to do is we have to realize that we also, although we want to test the whole, we also want to actually remove the framework from what we're testing, right? And this is why. Normally what happens is you know, even if we were to follow the test the whole, normally what we get without structure, we get chaos. And what happens is that we get a code base with, you know, lots of different types of tests, lots of different types of component, and lots of our own code. Now, most people know that they would want to keep data transfer code away from away from components and stuff like that. But I don't think most people are necessarily as rigid as they could be. And the reason for that is because frameworks move so fast that nobody really spends the time to learn, well, how do I shield myself from these frameworks? How do I get underneath and actually architect a software so that the framework is not in control? And what we get is this, most code bases, and I'm sure you've seen this, most code bases end up as this big mishmash of tests and code and components, and they all sort of get thrown in together. And this is, you know, this is normally what happens, and this creates a problem. And we're just going to look at a couple of the framework example problems, right? So here's a React component, right? This is the first example of where the framework starts to get in the way of testing. And this is just a normal React component. And what's happening here is we've got the props.start and props.end is passed in, so every stuff is passed in here, and what happens is this creates a closure, okay? And all the closure means is that we have an open curly bracket there and a closed curly bracket there, and what's happening is that it's adding together the start and end, and it's summing it up in the total there, right? And it's writing it out now. If I want to test that, that's really hard, because the only way I can test that is to actually read the return of that statement. So I'm going to have to start digging around in that entire string or that HTML, wherever it's returned. You see, this is a closure, so nothing can access it. Yeah, just pure function, but of course it's returning something. So I'm going to have to. The only thing I've got access to is that, you know, that HTML block there. And so this is really hard to test code like this, right? We really want to create something, you know, and that's because of the framework. The framework dictates. The framework reads that structure. React knows that structure and wants it to be in that structure. So, you know, it creates its purely functional components, right? So the React has taken the option away from us to read what the total of that is. So The other example is Angular. Angular has this end-to-end tests, and they all do. But this is an example of an end-to-end test. I just Googled around and found this online. And Angular's end-to-end testing is like any other end-to-end testing, and ultimately what it does is it uses something like Protractor or one of the other ones that I can't remember what the other one we used to use was a few years ago. But yeah, fundamentally they're all the same. What this does is this is just an in-memory browser. So it's a headless browser, I think it's called. And what it will do is it will go to, it'll go and get a page, and then it will read that HTML, a bit like we saw on the React one. And then it will use CSS to find the right place in that HTML. And that's great if you write great CSS, but we haven't even mastered architecture yet, and then we're now trying to write CSS. And the problem is that they're both sort of doing different jobs. And so the problem is that we are trying to now build CSS and views that are testable, rather than just making our code testable. So it depends on really what you want. But so the problems that this sort of thing causes is that we get this confusing stuff here. And in my experience of this over time is this doesn't scale very well, because now when you want to change you want to change the layout of things on the page, your tests break. The software's still working. I mean, I've just moved something. I might have nested an element. The software is still working. But the rendering has changed, the visualization of it has changed, and now my test breaks when really it was just a trivial UI level change. So this is the sort of problem that we see with Angular, and just so I'm not picking on React on Angular, I'm going to pick on Vue.js now. Vue.js is another framework thing, and it uses snapshots, much the same as React does. And this is returns an error for valid code. Well, I mean, for me, again, this is just something I found online. I was like looking through it, and the problem with snapshots across these frameworks is that they, you can't see immediately what the actual output to that is, right? You have to go and look on disk. If you most of these snapshot managers, you have to go and look on disk, because you have to write your snapshot on disk somewhere, and it's stored in memory. Which means I have to now go into another file to check what the output is, and normally those outputs are massive. They've got lots of HTML buried in them, unless you use mocking and you make it so small, but then you get the problems with problems with false positives. So the problem is that you've now got obscure inputs and outputs to your tests, which is really what you don't want. If you want to write good testable code, then you need good inputs and outputs. And here's what good inputs and outputs gives you. We typically, all of these problems, these last three problems that I've shown you, typically result in something like that you see at the top here. They want the way they want you to test is they want you to iterate some HTML, and then they want you to understand things like CSS here, and HTML, semantic HTML structure here, and HTML 20-year-old tags here, and they want you to iterate them, and then they want you to check that output. But this is mad, because this is just too complex to actually do that. Now you can use things like page object models, but problem with page object models is, again, you're just collapsing it down behind another layer, and if you change any of that CSS, you still break your page object model. So really what you want is you want to remove the framework, and you want to just boil everything down to just clean objects. And this is what's this bit here. And the clean object just represents that customer page. It is an abstraction of that customer page. It's not the actual custom page. It's a clean two-dimensional abstraction of that customer page. And what it says is that you just use simple objects to represent where something like the main title is. Okay, so main title would live inside the H1, right? And then you pull out that main title and you test that in isolation. And that means that you're going to be able to do this. What we used to have, or what we have when we follow the default process, is that we have a test that starts, and when we put the framework in control, the test will start, and it will pick up the component and start it. If we snapshots, or if it's end-to-end testing, it will pick up that component and it will invoke it, and then it will run a load of our code. And then that code will need to do some I/O maybe with the browser or with the HTTP module, do a fetch or something. And then, the test ends, right? And we get some sort of, a lot of tests ends up being like this because we're forced to be like this, right? Because we haven't got access. We're putting too much information in the framework. We haven't got access to that stuff because the framework hides it. So So really what we want is we want to just take the framework out of the equation, and we want to just, we don't need the component, we don't need the IO sort of stuff. We want to just start the test, run all of our code, and then end the test. And then what we do is we pass the resulting output to the framework, but our tests are nested, okay, are nested just before you pass back to the framework, right? So this is where we find this new way, which is actually an old way. But I think has maybe been, if this isn't news to you, it's maybe lost in translation, because we're so, I think as an industry, so fixated on frameworks that really this way of testing an app, this way of getting this efficiency of finding the sweet spot, we seek the tests around our code, and what we call our code is the true app. So we call it the presentation and the business logic, and we test that in isolation, but we test it as a whole, right? And that's what creating the testable architecture is, right? And then what we do is the output to our code, we just simply pass that off to the HTML framework renderer, which is React, Angular, or Vue, right? And we just keep a very, very clear line down the middle. And what this enables us to do is to develop tests fast, right? And as I said to you at the start of this talk, I'm not. My history isn't really in being a guru or writing books or anything. My history is from a commercial background, and having made this course into something that we use with our clients. So I wanted to just show you how well this works by actually showing you some code that's been anonymized, but this is from a customer's code base. And in this, what we do is we use something called the fast test architecture, and I'm going to tell you what the fast test architecture is at the end, because we've actually put it into a course. It's a 6-week training course, and the course actually, this particular video that you're watching, or this live stream that you're watching at the moment, it's sort of the foundational material. We don't let people do the course until they've seen this video, because they have to understand what they're getting themselves into. It's just complex stuff. So this works really well, right? We have used this with customers, and we have big teams that are using this, and this is the sort of code it produces. And 90% of our code looks like this. Our test code, 90% of our test code looks like this. And I remember when we started, we have one project that we started a few years ago, and the engineers at the time, there was a little bit of resistance, but as they slowly got into this, they suddenly realized what this is all about. And it's about having really clean tests that test specifications. I can pick that test up now and just say, should display a list of users, right? And what's happened here is I've gone off to something we use inversion of control containers and whatnot, but we go off to some abstract service. We pull stuff back, and we are really populating an entire system under test, and we're keeping it as a whole, but we're taking a lean approach to it, and we're testing that our software actually works, but without including the framework. And this is the power of this testable UI architecture. Okay, this is what you get. You get clean tests that are fast to write. And when stuff is clean and are fast to write, it's going to keep you in that flow channel, right? And when you do that, you're going to get high test coverage, which a lot of people get anyway, but the test coverage is going to be high value. You can't tell whether it's high value from a tool. You make it tell whether it's high value from tools. You have to go in and look at the architecture. And that's really what I wanted to impart with you today is to get a good architecture, and that your tests you actually are connected to your tests, and you want to maintain them because they truly are good tests. You're not just doing it because you are told to, or you're not just doing it because you think you should. You're doing it because you found a process that puts you in flow and makes you you find it so easy that why wouldn't you do it, right? This way of doing it is so great. I found personally because I can get distracted. I know I can get distracted, and I can come back to it, and I know exactly where I am. So really, really fantastic. So putting it all together, really what today's talk has been about is finding out some secrets of this testable UI architecture, and is really just understanding this testable UI architecture is a single page app. In it you have two apps. You have your UI app where you put your framework code, and then you have a business and UI presentation concern section, and then you test that in isolation. So from a bird's eye perspective, what we've learned today is that testing won't get done unless it's simple, because it will take us out of the flow channel. Nothing happens outside the flow channel apart from anxiety or boredom. And so what we need to do to have better testing is we need to create a testable UI architecture. And we saw how taking a lean mental model to architecture will help us make decisions. Okay, that's our the first thing that hopefully you've learned today is how to make good decisions, because if you make good decisions, then you won't need to ask too much. Having frameworks to make good decisions is as important as the decisions themselves. The second thing that we saw is how the testing documentation advocates, and sometimes promotes, isolationism and mocking, which if you don't know, I say don't know what you're doing. If you don't have the right mental model, the right mental cap on, what's going to happen is that this can cause false positives and a lot of coupling, right? So what we want to do is we want to test the whole, and in order to test the whole, we saw that we need to have a testable UI architecture, but we need to dial out of the frameworks, and we need to find a framework agnostic way, a framework separated way of testing, of actually testing of exercising our system under test. So this particular talk that you're seeing, it's the foundation of a 6-week training course, which covers in week 1 we do architecture, and we teach you how to lay out all these files. Then we talk about execution, and we teach you the differences between async and await and observables, and specifically when to use them in a UI architecture. And then what we do is we teach you how to make a simple test, just a simple state test, and then we show you complicated tests, which are the car is moving, and we show you how to take that through multiple loading and state changes within the test without using the framework. And then the final, week 5 and 6, is we teach you how to create a vertically scale a test suite so that you are getting maximum code reuse, but you're still testing the whole. And then we show you how to horizontally scale it, where we show you without using the framework how you can actually test a UI, and we can have an architecture that mimics what's in that UI, and you can make tests where you can invoke one part of the screen, but then another part opens a repeater or even an asynchronous repeater control, but you're not going to do that with framework code. You're going to do that with abstracted code, okay? And those tests will be robust. 9 times out of 10, you can get that code and drop it into your framework, and it will work first time. So if you would like information about this, I'm going to give all the details to Aris. If you want to redo this course, it's available on our main site. If you want to redo today's talk, it's a little bit different than one we have on the site, but you can do that. It's a 3-day email course. The 6-week testable UI architecture course, it's normally invite only, but if you go to that link there, you'll get an invite, and it has some information about the course, including the pricing. And today we have a 47% discount coupon that is active until close of play Friday, just for you guys. This hasn't gone anywhere else. So if you would be interested in taking that course, you just need to visit the link there, put your details in. It will send you the course info, including the full schedule and when it happens, etc., and the syllabus, in the pricing. And then you just get this coupon will give you a 47% discount on that, available till Friday. So I hope you've enjoyed it. I hope I haven't run over. Got 10 minutes left. Any questions?
While we're waiting for any questions, how many companies at the moment are they using this approach that you just mentioned, Pete?
3.
3.
Yeah.
And what kind of results do you see in terms of moving outside of the framework?
So we launched this course in January, and we've noticed that we've got one case study that we've done with they're a fintech company, a rapidly growing fintech company. And we've seen around about a 30% improvement in overall development speed. And the way we were able to measure that is because we were basically rebuilding a platform, and we had data off the last platform they built compared to rebuilding it this time. So we started with them. Funnily enough, they were a company. I started with the CTO there 5 years ago and, used the methodology that it was in my head at the time back then. And that's why he asked me, could we meet up and, look at this new project they were doing. And, we've seen a significant speed improvement, compared to the old way they were doing it. And, generally the sentiment with all of the engineers, both the senior and the more junior engineers, is they compared to working in the old code base, which was just what we call a smart UI, which was just two layers. This way is just so much easier. They can write tests fast. They feel more empowered. And I can honestly say that I've with it recently, professionally, I've never been in the situation where I could explain how to do something with someone and put the framework in front of them and just see them become architects themselves. I've always had to do the work myself as a professional. And it's only recently that I've seen how well this technique works, because it really empowers them to take control of the architecture. It really empowers them to do what I've always naturally done. And so it's really working out well. So it's fairly early days for it, but we're getting some some really, really interesting results at the moment.
And so that's this in the previous one of the previous talks we had. It was about Cypress.
Oh yes.
How do your tests connect with this kind of approach where we can use platforms like this to basically run our tests through the cloud?
Yes. So the Cypress question comes up quite a lot. And so what I usually stress is that Cypress is a tool. It's an end-to-end or integration testing tool. But this approach is about that's a tool, and this is a concept. And so what we're doing here is we're saying, if you want to use Cypress to drive this architecture, use Cypress. But Cypress, you'd probably use something a little bit less heavyweight. Probably something like Jest would be enough to run these lean tests, to run these fast tests, And what you would do is you would just say, well, let's run our specification via a simple test framework like Karma or Jest. And what that does is that brings that challenge down. It brings that heavyweightiness down. It brings that cost down, which increases the value, which improves the chances that the developers, the engineer is going to pick it up and run with it.
Okay, that's great. Questions we have is Testable UI compatible with accessibility features?
Accessibility, absolutely. So what would happen in that scenario? In fact, it works really well with that, because if you imagine, what happens is that you have this imaginary boundary, and outside that imaginary boundary, you have your true app. And your true app normally doesn't have accessibility in it, because your true app is just in-memory representations of whatever you physically need to code, right? Normally what happens is that when you pass it back to the framework, at that point, just after you've left the boundary, the black box that we talked about, after you've left the black box, what happens is you then pass that to the framework, and then the framework takes over your accessibility. If you want to test your accessibility, then what we usually recommend is you test that in isolation with the framework to make sure that if you get past a rubber duck, that a picture of a rubber duck or the audio of a rubber duck comes out on the framework, right?
Yeah.
So it helps you. It helps you get very clean, which actually would be good for accessibility, and especially it's good for your users, because you're less likely to have accessibility that breaks. I can't imagine how frustrating it would be to need accessibility and to not have it working. It's probably the thing we should get working first.
That's great. I don't know if there are any other questions. One of our attendees is asking if you could post the link that you mentioned in the actual chat.
Yeah.
But what we can do, we can send an email to the people subscribed to this meetup for them to go and access it afterwards.
Yeah.
So the slides will be available after this talk onto the playlist that Pusher is giving to us. We will also send a link through our normal newsletter and announcements. Thank you very much, Pete, for accepting to come and talk to our meetup.
Yeah.
We hope to see you in the next meetup or in a conference. We'll keep in touch. And thanks everyone for attending. And I'm gonna close it down now, and we can all get back to our work. Thank you very much.
Cheers.
Thank you.
Thanks, guys. Bye.
Thanks, sir. Thank you.
Bye.